everyone, and welcome to the Product Design and Manufacturing Collection webinar. My name is Carolina Fernandez, and I work in both marketing and sales here at MicroCAD. To start off, we have our presenter today, Phil Marshall. He's an expert in the industry and has a wonderful presentation for you all today. And as a reminder, you have on the left-hand corner a question box, and we'll be answering any types of questions that you have at the end of the webinar. But you can ask the questions at any point at the webinar today. And we also have some resources at the top right-hand corner, so be sure to check out those. And just as a reminder, we also have 15% off training. We're currently running our summer promotion. And without further ado, I'll pass it on to Phil. So Phil, you can start sharing your screen.
You have my screen now?
Yes.
Marvelous. All right, everyone. Good afternoon, and thank you for attending our webinar on digital prototyping. This certainly is a topic that's got a lot of interest, and a lot of people want to learn more about how they can stay competitive. As a company, MicroCAD empowers design professionals in the construction and manufacturing industries to increase productivity and meet project goals. With 30 years of experience as a minority-owned business, we pride ourselves in working with clients through every stage of the design process to assess needs and provide tailored and effective solutions. Today, we're focusing on digital prototyping as a competitive business process. So let me start by asking you a question. Are you happy with your product development process? It's not a trivial question, since for many industries, your ability to deliver innovation is key to your competitiveness. If you answered no, then this webinar will show you how other companies are being successful. If you answered yes, then pay attention. Your competitors are listening and working to improve their process. So let's talk about new products. Throughout recent history, companies have introduced new technology and products, and they have been accepted, usually slowly, by the masses. There's always been early adopters and laggards. In the case of the wired telephone, it took about 70 years from first introduction to 90% usage. Other new products and technology followed. Cars took about 70 years, electricity about 50, refrigerator about 40. More recently, microwaves and VCRs, or whatever VCR is, took about 20 years to reach 90% usage. Computers and internet took about 15 years. Cellular phones, not smartphones, took about 12 years. And we see the slope is getting sharper and sharper. Facebook, smartphones, and tablets got to 90% in less than 5 years. So we can see the trend. What this tells us is that the pace of product development has to match the pace of technology adoption. To be competitive, you have to speed up development and get products to market faster. If you don't have the next generation of products in the development pipeline when you introduce your latest and greatest, then you're behind. And if speed alone the speed needed to compete isn't intimidating enough, the complexity of the products is increasing. Many more products now have embedded microelectronics and intelligent sensors. There's over 50 billion internet-connected devices. These are part of all kinds of products and environments: cars, industrial machines, buildings, security systems, jet engines, game consoles, VR devices, and many more. And they are connected to each other in a way that was impossible 10 years ago. So your product engineering requires significant electrical, electronic design and analysis expertise and capabilities to perform those designs, as well as the mechanical design. So what you need to meet your product development goals spans many disciplines: mechanical, electronic, communication. You have to accurately predict the performance of your yet unbuilt product, and you have to be able to ensure the manufacturability of the product. And each discipline needs to be able to do their work synchronously to minimize development times. This means that one digital model they could all share. All this under heavy time and cost pressure. Remember, the product development objectives are speed, agility, and risk avoidance. So how do we get there? You need a set of tools. You need design tools to let your conceptual designers innovate freely. You need engineering tools to build the models and test its performance, mechanical, electrical, thermal. You need tools to create a physical prototype using rapid prototyping processes, both additive and subtractive. And you need tools to verify the manufacturability and to plan the production process. Most importantly, all these tools need to share data about your product so that the disciplines can progress simultaneously. To keep track of the progress, you need to manage all of the design data your team is creating to ensure that everyone is using the most recent information. And everything should be ready to handle changes. Lots of changes. In fact, the product development team should consider these inevitable changes as a good thing, not something to be avoided. Each change is an opportunity to make the end product better. Given these needs, what can MicroCAD and Autodesk do for you? We are experts in the Autodesk line of software products, which give you the tools you need. Autodesk provides a set of interoperable tools that lets your mechanical designers work with your electrical designers, provides PCB design and analysis to your EEs, lets you scan reality and reverse engineer existing parts, predict the performance of your finished product, stress and thermal, all on a platform that manages changes and ensures everyone has access to the latest data. What are these tools? To capture reality and reverse engineer existing components, ReCap Pro manages the point clouds created by laser scanning hardware and allows the models to be used in other 3D modeling systems. Fusion 360 is a full-featured cloud-based design and engineering system that addresses the needs of a mechanical, electrical, and PCB designers. Being cloud-based, Fusion 360 is great when your design teams are not co-located. You can work on a Fusion 360 design from anywhere. With both feature-based and direct modeling, it's especially useful early in the design stage when the form of the product is undergoing lots of changes and tweaking. With built-in analysis tools, Fusion 360 lets you predict product performance early in the development cycle. Fusion 360 creates CNC toolpaths to be sent to your 2 through 5 axis CNC machines, as well as generating designs for 3D printing. Inventor. Inventor is an established 3D modeling system with powerful features developed over years of experience. Inventor handles extremely large assemblies. We have customers with 40, 50, even over 100,000 parts in their assemblies. Dynamic motion can be simulated to see how mechanisms behave. Inventor Nastran includes FEA analysis tools for stress and thermal so that the designer can verify performance of their design. Linear and nonlinear, impact, dynamics, complex motion, and thermal stress problems can all be solved with Inventor Nastran. Inventor allows users to perform 1D tolerance analyses to determine the fit of components in an assembly. There is always a trade-off between precision and manufacturing cost, so this functionality lets the designers try different tolerancing schemes to get the balance that they want. Embedded into the modeling software is the capability to generate 2.5 to 5 axis CNC toolpaths for mill, turn mill, lathe, and drilling platforms. The operator can also create 2-axis planar toolpaths for water jet, plasma, and laser cutting. Factory design utilities. With this software, the designer can plan and lay out a factory using 3D components of machines and material handling systems from libraries. Built-in interference checking makes sure that the layout doesn't have any coordination problems and guarantees access to all of the equipment. If the factory is being built as a new construction, the plant's engineer can keep up with the building design and the systems within the building using Navisworks. It aggregates models created by the architect, the consulting engineers, and the construction company to make a single viewable model. In this consolidated model, the user can check for interferences and manage the resolution process. Included in the collection is Autocad, the workhorse of CAD, as well as the base software. The 7 specialized tool sets for Autocad are provided: architectural, mechanical, electrical, MEP, plant 3D, map, and raster design. So you have the ability to use those tools you're probably very comfortable and familiar with. Each of the tools we just talked about provides productivity for specific purposes. They're all interoperable, that is, designs and models created in one can be used in another. To control all of the data, you need a management system, which is what Vault does. Vault provides a single source for all of the design data and maintains version control so that everyone has access to the most recent data. You're never caught working with outdated information. The Autodesk Product Design and Manufacturing Collection then combines all of these software in one package, making it easy for each designer to select the tool best suited for their job. With the interoperability provided, the team can share data easily, and with Vault as a data management system, you can ensure that each user has access to the most recent version of the data. These tools will quicken the product development cycle because the various disciplines can work simultaneously, sharing data as they do. As the model develops, engineers can verify anticipated product performance using the analysis tools, so there are no surprises. Physical prototypes can be easily made from the model using either additive 3D printing technology or subtractive machining processes, and the manufacturing engineers can plan for production by laying out the factory and planning product flow. The use of these tools will enable a team to handle changes quickly and easily. Changes from one discipline will be visible to all. The data management system keeps track of the changes and ensures everyone has access to the right information. With the entire team working together, the development process will be exposed for the project managers to see the status of every sub-project. No surprises. And the use of analysis to verify product performance prior to the first physical prototype means more predictable testing process. So these tools provide you speed, agility, and risk avoidance, just what you were looking for. These very powerful tools, the key to using these successfully is to integrate them into your environment. MicroCAD will help you tailor the tools for your particular use, making legacy data available, integrating with your existing business systems, and providing whatever training, support, and hand-holding is necessary to make you successful. I asked you at the beginning, are you happy with your product development process? After seeing the way that others, perhaps your competition, can handle simultaneous development from multiple disciplines with everyone sharing the most recent data, do you see how you could be happier? A faster, more flexible, and more predictable process. Who could argue with that? Let's move on and handle any questions that have arisen.
All right, thank you, Phil, for the webinar. And I'll open up the floor to questions. Again, the chat box in the left-hand corner, feel free to ask any questions. Let's see. We have some coming in now. One is, what is the difference between Fusion and Inventor?
Yeah, Fusion and Inventor, they have a lot of overlapping functionality. Some of the key things that do differentiate them. First, Fusion 360 is a cloud-based package. So if your design team is geographically located in many different locations, then Fusion would enable them to access the same data in the cloud at the same time. So for remotely working end users, the Fusion 360 is a good choice. Inventor, on the other hand, is an established package that's been around a long time. It works very well with very large assemblies. As I said, we have users with 40, 50, maybe even 100,000 parts in their assemblies, and Inventor can handle that very nicely. Inventor also, because of its longevity, have existing libraries of the common components that you would use. Not just the nuts and bolts and gaskets, but also the air cylinders, the hinges, all of the mechanical components you might use in your part, in your design, that you just want to reach out and put it in without having to enter any data. So there are libraries of the common standard components, and there's libraries from vendors who work with Inventor. So Inventor has libraries of components. So if you have complex designs, then Inventor may be a good choice. But both of them work very well, and they can work together. So you might use Fusion in the early stages while you're doing your conceptual design, and the design is very fluid, and switch over to Inventor as the design gets more fully detailed and gets heavier.
All right. So another question. If we've built a library of AutoCAD designs, how can we use them?
I think everybody has libraries of AutoCAD going back 20 years or so. So these AutoCAD designs, very valuable. I'm not minimizing. Someone has invested a lot of time and effort into making these libraries of components, and you definitely don't want to just walk away from them. So typically what you can do is, if you want to use those as a basis for your 3D models, you certainly can bring them into either Fusion or Inventor. Use the 2D sketches and build the 3D models from them. It's better to start from the existing sketches than it would be to start from scratch. But there also could be cases where you want to use the 2D just as 2D, because these are legacy parts that aren't going to be redesigned, and you just want to include them in the assembly. So you could include them in a 2D fashion, so they're almost like ghosted into the assembly, to show that these parts exist without having to model them in full detail. So you can continue to use the models that you've built in AutoCAD either as a starting point for your 3D models, or as is if you're not going to be making any changes.
All right. And then, will I need new hardware?
Well, obviously that depends on what you have now, but if what you're using is, if you're comfortable with the performance running, let's say, AutoCAD, then that machine should be adequate to run the software that we talked about here. Obviously, if you get extremely large Inventor models, then that's where you may want to add some memory. But on the other side, if you're going to be using Fusion 360, since most of the calculational work is done in the cloud, then you would need less of a machine. So it depends on which of the tools you're going to use at which time. But if the machine you have now is comfortable doing heavyweight AutoCAD work, then it will be sufficient for all of these tools we talked about.
Okay, and with that, that concludes the question portion of the webinar. If there's, as a reminder, we do offer training at MicroCAD. You could have custom training with Phil. We can even look into group training as well through our microcad3d.com website. We have that summer training promotion going on now, so great time to take advantage of that. And any other services, whether it be plotters, scanners, or drones, or any type of Autodesk software, we're here to support you in any of your project needs. And without further ado, thank you, Phil, for the wonderful webinar, and to all our attendees. We look forward to the next one, and be sure to be checking out our website, as we'll be updating more and having more webinars going through the rest of the year. Thank you, Phil.
Thank you. Thank you for your time.
Take care. Bye-bye.